All right, this is lesson 4.1, triangles and angles. Today we're going to learn about a brand new shape you've never seen before. It has 3 sides. It's called a triangle. You can classify triangles by their angles and by their sides. If they have 3 sides the same, it's called an equilateral triangle. If 2 of the sides are the same or more, it's called isosceles triangle. And if no sides are the same, it's a scalene triangle. You can also classify the triangle by its angles. So if all 3 angles are less than 90, it's called an acute triangle. If all 3 angles are the same, it's called an equiangular triangle. Notice it has equal angle, so equal angles, just like equilateral had equal sides. A right triangle has a right angle in it, and if it has just one obtuse angle, then it would be an obtuse triangle. You cannot have more than one, because then the angles would add up to more than 180 degrees. Classifying triangles. You want to be as specific as possible, so you should mention something about the angles and something about the sides. For example, triangle ABC has 3 acute angles. All 3 are less than 90. So I'm going to call this an acute. And I also know all 3 sides are going to be different because all 3 angles are different. So I'm going to call this scalene, because the sides are different. Scalene. There we go. How about for triangle DEF? Right away I see that one of the angles is more than 90, so I know right off the bat that this is going to be obtuse. And then I also see that it has congruence marks here and here, showing that 2 sides are the same. So a triangle with 2 sides or more the same is called isosceles. Isosceles. I think I spelled this wrong. Let's check. Yeah. Let's switch that for a E. So an obtuse isosceles triangle. All right. So let's give you guys a second to try both of these examples. So hit the pause button. Take 30 seconds to a minute to do these 2 examples, and then we'll look at them. All right. So hopefully we got all 3 of these angles are the same. So we call it equiangular. And if you know that all 3 angles are the same, you actually know that all 3 sides will be the same for a triangle. So this is also an equilateral. For this triangle, all 3 angles are less than 90. So we know it's acute. And 2 of these angles are the same, the 46 and the 46. So we know that the sides opposite the angles will also be the same as each other. So this will be an isosceles. So acute isosceles. All right. Let's take a couple minutes and do the classwork. This will be 4.1a. So make sure you label your paper with your name, 4.1a, and period, whichever class you were in. So just make sure you push the pause button so you have enough time to answer these questions, and we'll move on. All right. A triangle with 3 different sides would be scalene. A triangle with 2 sides the same would be isosceles. A triangle with 3 sides the same would be both equilateral, and we know that it's going to be equiangular also. A side with 3 angles the same is equiangular, and we know that it would also be equilateral. With a 90-degree angle would be a right triangle, and with over 90 would be obtuse. This triangle has all 3 sides under 90, so it will be acute. And 2 sides are the same, so isosceles. This triangle has a 90-degree angle, so it'll be a right.
Stacy, can you say your right is outside? Again, Stacy, can you say your right is waiting outside?
Triangle, and 2 sides the same, so isosceles. This triangle has an angle that's bigger than 90, so it'll be obtuse. It has no congruence marks, so all 3 sides are different, so obtuse, scalene. We can follow that pattern for the rest of these, and we'll get our answers as a right scalene, a acute isosceles, or obtuse. So for this one, they're saying that this angle is greater than 90. Oh, so how would we know that that's greater than 90? So all triangles always have to add up to 180. So angle V plus 42 plus 42 has to equal 180. So if you add these up, we would get 84. And if we subtract 84 on both sides, we get angle V equals 96, hopefully. All right. Which is more than 90, which would make it an obtuse isosceles. So you have to be careful when they don't show all 3 angles, which you calculate them out. This one shows all 3, and they're all less than 90, so we know it's acute. And all 3 are different, so it will be scalene. So acute scalene. Right. So back to our notes packet. if we're looking at angle A, right here, the sides that are next to it or touching angle A are called adjacent sides. Sides that do not touch the angle, so no part of the side is touching this point right here, are called opposite. And the point of an angle is called a vertex. This is a vertex. When you have a right triangle, the two sides that are touching the right angle are called legs. And the largest side, opposite the 90, is always called the hypotenuse. You might remember that from Pythagorean theorem. A squared plus b squared equals c squared. The c squared is always a hypotenuse. With isosceles triangles, the two sides that are the same are called legs, and then the third side is called the base. So let's take a second and pause the video and fill in the names for each of the sides. All right, so this one's a right triangle, so the two sides touching the right angle are called legs. And then the third side will be called a hypotenuse. Here we see that two sides are the same as each other. So this is an isosceles triangle. So the two sides that are the same are called legs. And then the third side is called a base. Right. So for this example, we have a triangular loom, which you guys will use next time you guys are knitting your own clothing. It's a very common thing for high school students to do. So this is an important one for you guys. And then if we look at this diagram, we see that two sides are the same, 5 feet and 5 feet. We also see that it has a right angle. So this would be a right isosceles triangle. So you could write something along the lines of two sides are the same and it has a right angle. Second part of the question asks, identify the legs and the hypotenuse of ABC. Which side is the base of the triangle? So the legs would be 5 feet and 5 feet because they're the same as each other. They would also be 5 feet and 5 feet because they're touching the right angle. The hypotenuse would be 7 because it's across from the 90-degree angle. And it would also be the base because it's the third side that's not the same as the other two. All right, take a second and do this example with A and B. And pause the video and we'll check our answers in a second. All right. For this triangle, it asks us to explain why the triangle is a scalene right triangle. So it's scalene because it has three sides that are different, and it's right because it has a right angle. So it has one right angle and the side lengths are different. Explain why there is no base in the triangle. A base is only for isosceles triangles. This is not isosceles because there's not two sides that are the same. All right, let's finish up these problems in our classwork. So pause the video and we'll go over the answers in a second. All right, an isosceles triangle is sometimes an equilateral triangle because when an isosceles triangle has two sides the same, it's not an equilateral triangle, but when it has three sides the same, it is. Because an isosceles triangle is two or more. So that's kind of a trick question. An obtuse triangle is sometimes an isosceles triangle. So you could draw an obtuse triangle with two sides the same, or you could draw an obtuse triangle with three different lengths. Identify the legs and the hypotenuse of any right triangles from 16 through 21. All right. So if you look back onto the problem 16 through 21, number 17 would have legs for DE and DF and a hypotenuse of DF. And number 19 would have legs of RP and RQ and a hypotenuse of PQ. So those were both right triangles. 28, identify the legs and the base of any isosceles triangles. Which isosceles triangles have a base that is also a hypotenuse of a right triangle. So on problem 16 was an isosceles triangle. So CA and CB were the same, and AB was the different one, or the base. 17 was a right triangle and an isosceles triangle. So the legs DE and DF, and the base was EF.
I am Toddy Chavez.
And problem number 20 was isosceles only, and it had the legs VT and VU and the base of TU. All right. Number 45. Identify the legs and the hypotenuse of the right triangle formed by the wing deflector. All right, so we have this diagram here, and identify the legs and the hypotenuse. So we have a 90-degree angle here, so MN would be one of the legs, and NL would be the other, and then the hypotenuse would be across from it, which would be ML. It is generally recommended that the upstream angle should range from 30 degrees to 45 degrees. Give a range of angle measures for the downstream angle. So we know a right angle is 90 degrees plus our upstream angle, so M, plus the downstream angle L should equal 180 degrees. So knowing this, we could subtract 90 on both sides. M plus L has to equal 90 degrees. We subtracted 90 on both sides. So we're looking at the upstream angle, which is M, can be 30 to 45. So let's plug in 30 and see what happens. So if we have 30 plus L equals 90, and we subtract 30 on both sides, angle L would equal 60 degrees. So that's the biggest it could be. And if M was 45 degrees, and subtract 45 on both sides, we would get L equals 45. And that would be the smallest L could be. So the range the angle L could be is between 45 and 60 degrees. I'd probably write it like this. Right. So let's go ahead and make sure we do the homework assignment for 4.1a, and I will stamp it tomorrow for full credit. Thank you. Have a great day.